Today we're going to be solving the valid parentheses problem on Leetcode, which is problem 20. It's also an easy problem, and it's a great problem if you want to up your game when it comes to data structures in Python. Now, as per usual, I'm going to be solving the problem cold. We'll see how long it takes me. Then we're going to go over the optimal solution and runtime. And at the end of this problem, we're going to be going over the key takeaways from solving this problem and what you can carry forward into your next Leetcode problem. The timer starts now. Okay, so this problem we're given a string, and with just these characters, and we want to determine if the string is valid. The string is valid if open brackets are closed by the same type of brackets, and open brackets must be closed in the correct order. Correct order. So if it didn't say the correct order, I probably would use a hash map or dictionary, because then you can just check and see if the number of closing brackets equals the number of opening brackets. But because they need to be in the correct order, you're going to use a different data structure. Fantastic. I ran that way more times than I'm comfortable running it, but here we are. We beat about 72% of these solutions submitted for this particular problem. So in this particular problem, we used a stack data structure. So if you're unfamiliar, it's basically like a stack of pancakes. You throw one pancake on, you add another one, you add another one, you add another one, and you can only remove pancakes from the top. It's not like Jenga where you can just take stuff out of anywhere. You can really only remove the one that's at the top of the list. So the reason why we wanted to use this solution for this particular problem is because we knew that it had to be closed in the correct order and it had to be closed by the same type of bracket. So like let's say we have the original kind of curved parentheses and we put that on our stack, and then we have another curved parentheses and we put that on our stack, and then we get a closing bracket. then we know when we pop our last one that's curved, it's not going to fit with the closing bracket that's square. So this stack data structure is super, super helpful in solving this particular type of problem. Now let's go ahead and look at the code. So we can see here that there's probably some optimizing we could do, but in general, it fits the problem and it fits all of the test cases. Going into the runtime of this problem. Now, if the string is ro of n, we do have to go through every single character in the string in our worst case scenario. In this case, our worst case scenario is that we actually return true. Just because you're returning true doesn't mean it takes a shorter runtime. So in our case, because we have to check every single character to make sure they all match up and go through the entire string, our worst case scenario is O of n. So if we quit earlier, we might get like O of 1, O of 2, but we always do the big O on this channel, which is the worst case runtime. One of the big takeaways from this particular Leetcode problem is knowing your different data structures so you can apply them to each of these problems coherently. Because in this case, if we tried to use something like a hash map, that wouldn't have really worked because it wouldn't be in order. We'd have no way of really checking that unless we were using like 2 hash maps or a hash map and a list or something like that. But just using a stack was a lot easier for this particular type of problem. So when you're solving a problem like this and you know that there's probably some data structure, or you're trying a few data structures and you're like, these don't really work in my head, just keep trying them because there's probably one that fits, like the stack fitting this problem. Another thing to note is that Python is different than most languages in that you don't need to use a special function to compare strings. You can just do an equals equals. In this case, we didn't need to worry about that because we were using characters, so it wasn't a big deal. Now, I hope you found this video helpful, and if you're interested in more of these types of problems where you can solve them using a specific data structure, make sure to check out our video from last week on the two-sum problem. Thank you for watching, and have a good rest of your day.